Hey guys, in this video we're going to be considering partial derivatives and we're going to be looking at two examples. So in the previous video we dealt with some basic derivatives and integrals of single variable functions. But say we have a function of two variables. At first glance you can't solve this using standard integrals. What we do instead is we treat one variable as a constant and differentiate the other. So I'm going to define a partial derivative in terms of x as f dash x b, where y is treated as a constant b, and the derivative of the function in terms of y is f dash a y. So doing this, we end up with two partial derivatives that we can use to find the total derivative in the chain rule. So dfxy will end up equaling the partial derivative of f with respect to x times dx plus the partial derivative with respect to y times dy. And another way to write this is using delta. So here we have df equals delta f on delta x. So the delta notation means that it's the partial derivative of the function, and here we're looking at in terms of x, and we multiply that by dx plus delta f on delta y dy. So this also applies for functions with more than two variables. So here we have three variables, we simply add another term at the end. To integrate a partial derivative, we do the same thing. So we treat one variable as a variable and all the others as constants. But in doing this, you have to account for an additional function in terms of the variables that were treated as constants, and we'll see how this works in an example. So for our first example, we've been given the function which is in terms of three variables x, y, z, and we've been asked to find the partial derivative in terms of x. So we're treating x as variable and everything else as constants. X squared derives to 2x, so we've got 6xyz squared. For sine xy, y is a constant, so that will be y cos xy.